Right. A very good evening to everyone. Myself is Venkat. See, I'm the instructor and facilitator for this particular course. I hope I'm audible to everyone, right?
Yes, sir.
Great.
Yes.
Yeah.
Yes.
Okay. Today I'm going to give the demonstration about, a technology or maybe a course called, embedded automotive testing. Yeah. So I hope everyone have received the course content relevant to this particular course. Most of the people who are attending this online meeting, I hope for everyone I have shared this particular content. I hope everyone have gone through that. Yeah, this course is little, I can say little advanced to the earlier courses. See, most of the people who are attending here, somebody, freshers, somebody are experienced, somebody are working professionals, somebody are trying to change, trying to switch from one particular technology to another technology. See, as per my survey, hardly India wise, hardly 3, 4 people are giving a training on this particular technology, right? So, in order to understand this particular technology, as per my knowledge, you need, you have a commitment. You should be having a zeal, I can say. You can have a enthusiasm to learn a particular technology. That's all. I think that would be the mental commitment is required in order to understand this particular technology. Otherwise, I'm here to give you the best knowledge, whatever the background you require about this particular technology. See, I'm the PhD holder in this area. So my background is, you can search my background in the internet. That my background is artificial intelligence in big data analytics as well as data science, machine learning, electronics, mechatronics, IoT, embedded system, automation testing, Python, all these technologies I have worked on. So if you have any queries related to anything about the software industry, past 40 years to till to date, next 50 years also, I could able to give you the best justification about your queries. So I think if you have any questions, you can ask me after, once the concept is delivered to you. So the title of this particular course is, Embedded Automotive Testing. There are very important terminologies called embedded. There is an important terminology called automotive. There is a terminology called as a test. See, most of the time, electronics, electrical, some people and computer science people might aware about what do you mean by embedded. And comes to automotive industry. See, this car will be, automotive device, which means this car can be, without a driver assistance, it can travel, it can drive. Therefore, it is an automotive. Human intervention is not required. Therefore, it is an automotive device. Testing is nothing but it's a verification and validation. Earlier, we used to have a manual testing. Later, it has become automation testing. Later, it has become ETL testing, mobile testing, functional testing, white box testing. There will be a lot of names are there. Being a, embedded testing engineer, you will be test the hardware devices made with the software is going to be tested whether they are bug free or not. That's a terminology called as a test. Let's go ahead. You will be able to understand what exactly embedded, what exactly automotive, what exactly testing. Correct. So today I would be able to give you the justification within this 40 minutes of time that the topics are Why on embedded automotive testing becoming significant? This technology might be existing past 40, 50 years ago, but now few days, few months onwards, most of the world class people are talking about embedded automotive. Why? Because upcoming technologies, upcoming hardware devices and embedded devices are following this particular technology. So for whatever the technologies you are using at a industry, like full stack Java, full stack Python, automation, testing, AWS, Salesforce, CRM, ERP, lot of technologies you might be undergone, you might have listened, but still this particular technology has vital scope in the industry. Therefore, anybody want to learn this technology, definitely thousand time I can give an assurance that you will be having a sustainability at an industry because there is a huge requirement. The next topic I would like to talk about, what do you mean by embedded system versus Internet of Things? These two are the different keywords, but they are each correlated very strongly. You must know how embedded system is correlated with an Internet of Things. I'll be give you the justification about it. The next topic is that in your day-to-day life, what are the list of embedded system devices you are using? Probably you might not be aware that you are using an embedded system devices. Let me show you what devices you guys are using in our day-to-day life. Okay. Then I'll be show you, as there is a high correlation between the embedded system and Internet of Things, what devices you are using an Internet of based devices, IoT devices, what devices are going to be embedded system devices, how they different each other. Why don't we isolate them? Why don't we integrate them? There will be certain relations among them. Let's see the correlation among. Yeah. Then in this particular technology, the major contribution is going to become even manual testing is required, means the knowledge relevant to the manual testing, how to write the documentary, how to prepare the test cases combinationally and as well as automatically, and what are the tools are going to be used, what are the programming languages are used. I think you must aware them. Clear? Okay. And the miscellaneous topics you are going to learn related to computer networks, protocols, electronically, conceptually, mathematically, programmatically, miscellaneous topics you are going to learn. As a whole, I can say that this technology is not tough, but this technology is unaware to you guys. But once you start learning this technology, 100% you will be able to gain the knowledge, you can acquire the knowledge, you will be sustained in the market. Just you need a proper dedication and mental commitment towards the learning of this particular course. Is that clear? Yeah. Okay. Firstly, let me define what exactly embedded system, because we're all using embedded systems, but I think very few people are able to define what exactly embedded system. Please, I request participant, please don't write the things because I can disable your privilege. Okay. Okay. Right. So let me define what do you mean by embedded system. If you look at the definition, if you look at the definition here, ES indicates an embedded system is electronic hardware device in which a software is deployed or embedded on top of the ROM, ROM, which is read-only memory, not RAM. Random access memory is different. Read-only memory is different. On every laptop, on every mobile, every hardware electronic device will have a ROM. Otherwise, we cannot deploy the software. We cannot store the software. We cannot install the software. So any hardware electronically, software is installed on top of the ROM. Such a devices are going to be treated as a embedded system devices. The best example, I can see that, you know what, your washing machine, your refrigerator, your AC, a smartphone, Xerox machine, billing machine, all these are, embedded systems only. But this terminology, you guys never be noticed that it is comes under embedded system device. Correct? Okay. Let me show you the examples that, I just now I told a mobile is an embedded system where smartphones are going to be installed softwares on top of the secondary storage memories. If you look at the old phones, all they are the purely embedded devices because they would be installed the relevant software on top of the ROM. Okay. Washing machine is the best example where the washing machine is equipped with the fuzzy logic programming will be installed on top of the ROM. It will be work according to the interaction and intervention with the user. All electrical billing machine, bus billing machine, ticketing billing machines, all will be embedded system devices. Car dashboard, infotainment is the embedded system device. Steering cluster will be embedded system device. Bike dashboard, camera, all these will be comes under. These are the minimal examples I'm giving you, or else you will have a numerous applications you will have. Clear? See, when I'm talking about certain concept, I think in this meeting, most of the people already who are working in automotive industry, like mechanical industry, car industry, bike industry, and somebody already they are working in embedded devices like a car, Tesla, all this. Please, if you have any questions, you can ask me straight away. I could able to give you the answer accordingly. Clear? Right. Let's go ahead. Little go ahead. What are the areas, which means domains, I can say. Domains means what? Areas in which embedded system is going to play a much role over here. So the best examples are, you know, consumer electronics and durables, which means what? At home, most of the time we use a camera. Surveillance camera is the best example as an embedded system. It's a consumer electronics. Mobile is an electronics, isn't it? Remote, TV remote is an embedded system. Now, in fact, a television, a smart TVs are purely embedded system device. Do you agree with me? Because that's a durable. That's a durable device. Alexa, mobile, camera, fans, smart doors, smart Alexa, all these will be comes under, you know, consumer durable goods. They're all electronics relevant goods. Obviously, telecommunication is an industry where much more, where, routers, switches, gateways, protocols, lot of devices we have telecommunication devices are purely embedded system devices. Please, you have to notice them. Obviously, automotive electronics. Alexa is an automotive electronics. Obviously, the Tesla car is an electronics device. It's a mechatronics device. Yes or no? Your car key is an automotive electronic device. It has a sensor. Obviously, information technology, hardware, and office automation will have a lot of devices are statically developed as an embedded system devices in order to perform their particular specific task. That you have to be notice them. Anyhow, I'll be show you what are the devices or comes under what kind of domains. Apart from these domains, there are other domains where embedded system devices are required. Industrial electronics, you know, test and measuring instruments, obviously, our weight machine, in hospital, there will be lot of heartbeat measuring mission, BP measuring mission, even our temperature measuring mission, our many body symptoms are going to be measured by the electronic static embedded devices. Being a technical guy, you would be able to understand that it is the electronic embedded device. Clear? So apart from this industrial automation, defense electronics, defense means obviously it's a military area where the lot of devices are making as an embedded in order to perform their particular task. Clear? Let's go ahead. Apart from this, you have seen medical electronics, Internet of Things, IoT, and automobile industry, artificial intelligence and machine learning industry. Many more numerous example we have where we can able to see embedded automotive devices. Just you have to have a observation such a way that you can able to classify what device is an embedded system device, what device is an IoT device, what device is the smart device, what device is a mechanical device. You can able to classify them. Yes or no? Yeah, yeah. Now let's little go ahead. What is the combination of embedded automotive? Till now, we spoken about embedded devices, embedded softwares, how they will be correlated each other in a specific classification of areas. Let's we talk about what do you mean by embedded automotive? Means what? This particular concept, this particular technology major part contribution is going to talk and discuss, demonstrated about embedded automotive part. The best example is the Tesla car, self-driving cars. Most of the semi-self-driving cars, semi-automated cars, most of the time we are seeing in the market. Okay, what does exactly self driving cars? See, self driving cars going to be a best example where we are going to elaborate more and more. They are autonomous vehicles. Autonomous vehicles means what? They won't depending on much more things on the human intervention. They could operate without the human intervention. There will be human intervention will be there, but very negligible would be there. Very rare intervention will be there. So, so embedded automotive example electronic devices will be a self-driving car. Best example is Tesla. It's a self-driving car. See why such a cars we need to test because it's a highly, programmable device, highly automated device where the software will be equipped with which it is going to be work, in which there are possibility of errors will be thrown. Errors are going to be occur. Something goes wrong, it's directly proportional to loss of the life. Therefore, being a automotive embedded testing engineer, you have to test it not to have any kind of a bugs or defects or failures or errors. Clear? Yeah. Now, so here, in order to make such a autonomous cars or self-driving cars, we have to utilize advanced concepts like electronic sensors, computer-related algorithms, where they will be navigate the roads and potentially which will be revolutionize transportation, because the whole transportation becoming very easy because behind the particular device there will be smarter algorithms, smarter sensors, smarter programs, smarter electromagnetic, electromechanical devices are existing. It's all interdisciplinary, multidisciplinary devices are made as a one self-driving car. Self-driving at metro. Metro is not drive is going to be drive by the driver. It's a metro is a driverless bicycles, driverless cars. Many more are about to come into the market. Probably already we are learning many things about the things. So you are learning this course how to test autonomous devices, how to test embedded automotive devices. It can be a car, it can be a train, it can be a Hitachi, it can be other device. However, how you are going to test, how to develop them, that's your contribution, that's your way to learn. Right. So embedded testing. So what do you mean by testing? Obviously, as I said, so it's a process where the validation and verification a particular device is ensuring that a device not to have an errors, defects, bugs, failures. Correct? So any device you are going to make, we expect something. We expect something. It will behave something. So I can able to tell that deviation, deviation between expected expected and actual or different is called it's called a bug. It's commonly quite commonly going to be happen. So we have to make sure that during the testing process, a particular electronic embedded device should not have any errors. If the device has a limitation, we have to specify in a limitation process. This device cannot perform this particular task. If we give more load, the device is causes for abnormal behavior. That is supposed to be specified. So this is the testing I can able to say. Clear. So now let me give you how embedded system is different from the IoT. So here, the embedded system, if you look at embedded system is the software which is integrated with the hardware, which will be made with a microcontroller. Microcontroller. See, microprocessor is different from microcontroller. I'll be elaborate in future classes in much more better way. Microcontroller is made for a specific task to be performed, which is autonomously made to perform the specific task. So in order to make the embedded system device, internet is not required. So that's a difference. What is the second example, second difference? The embedded system doesn't require internet to perform a smart job. Whereas, if you look at IoT, IoT is an integration of embedded system with the assistance of an internet. The things will be globally communicate with the help of a wireless, with the help of a wired communication. Therefore, therefore, embedded system will be subset to the IoT. Therefore, I can say embedded system is the subset to the IoT environment. So this is an example of microcontroller where the embedded system does a specific task. But whereas this is a smart home, in the smart home, lot of devices are going to be remotely controlled, where there will be lot of subset of the miscellaneous embedded devices are going to become a part. Clear? Yes. So what are the list of embedded system devices you are likely to see in your day-to-day life? You see the devices, if you look at, you know, phone, landline phone is going to become a embedded system, isn't it? So this is a smarter car, smart keyboard, wireless keyboard. It is a joystick. It is the refrigerator, isn't it? It is an alarm. It is the phone, isn't it? So this is the a smart wash basin. So where it will be equipped with that, it will be able to predict something else, isn't it? So this is the it is going to be a router, we can say, or maybe it can be a extension box, I can say, electronically made. Sir, no. So this is the surveillance camera is going to be a smart device. Yes or no? Similarly, I can show you list of devices. You see, these are all list of devices. You can see here lot of devices. Most of the DVD drive, probably most of the devices will be comes under embedded. All these are the embedded devices. Television, camera, mouse, calculator, you know, all these devices, even AC, Xerox machine, all these will be comes under embedded devices. You see all these list of traffic signals, even Xerox machine, printer, even metro train, television, even though washing machine, tablet, mobile devices, even the display boards, bike, aeroplane, many more devices will be equipped with the embedded devices that is supposed to be noticed. Even ATM machine, Xerox machine, you know, you can see all these devices are comes under embedded devices. You can list out many devices. I have taken some devices where most frequently we use in our day-to-day life. Clear? So now, let me show you, because our course is going to talk about automation testing as well as embedded testing, which combinationally we are going to be discuss with the help of CAPL programming, with the help of Python programming, with the help of simulation tool called as a Kenoi, ADAS, UDAs, infotainment. There are a lot of things I have specified in the course content. You can go through that. In a smart car, in a smart car, whatever the names you are seeing here, everything will be one particular embedded system. Night vision control will be done by one particular embedded system. Airbox deployment is going to be controlled by one particular embedded device. Engine control is going to be monitored by one particular embedded device. Adaptive front lighting is going to be controlled. Adaptive cruise control ACC will be maintained by the one particular embedded device. OBD, electric power steering, electric throttle control, lot of electronic stability control, anti-lock braking system, whatnot, lane correction, battery management. I cannot list one or two. All these will be, many more individual embedded electronic control units equipped, but normally we never notice the car will have these many equipments are there or not. So you guys can work on a one specific area, another person will work on another specific area. Likewise, every individual embedded testing developer, or maybe embedded developer, or maybe embedded testing engineer will be working on a specific a narrow down area. One person cannot work on all these particular areas. Clear? So please, you have to notice them. Obviously, an embedded automotive testing is the technology which is going to be most contribution. I'm going to take it as a self-driving cars, which consisting of AI algorithms, sensors, computer vision, object detection, machine learning techniques. High precision mapping is required in order to make the embedded automotive testing, isn't it? Okay. Now, similarly, the safety is a very important concern whenever we buy a particular car. So, in the self-driving cars or maybe a semi-self-driving cars, where we achieved advanced driver assistant sensor systems, real-time data analysis called as telematics, redundant mechanisms, strict adherence to the safety protocols need to be followed, so that the safety is going to be a high prioritized factor in order to buy the a particular car by the rich people. So the self-driving cars have a potential significantly reduce accidents and human errors on the roads. So that in future, rather than purchasing, semi-structured or semi-automotive device, we are going to purchase the highly automotive devices, because they are having a significantly more error-free devices. Okay, right. So benefits, benefits of self-driving cars include improved road safety, reduced traffic congestion, and there will be protocols are going to be used, enhance accessibility, increase productivity, potential environmental advantages, much more things we are going to get. I think by seeing the pictures, what are the advantages we are getting? This is called, this part is called, infotainment. This is also known as IVI, in vehicle infotainment. This is going to be a virtual this is a cluster, we can say. So over the cluster itself, over the driving steering itself will be a lot of options will be there to connect to the Wi-Fi, to connect to the internet, to see the navigation, GPRS, to make a call, to see the messages. There will be a lot of facilities and mechanisms are provided that are all you are supposed to be test. Obviously, the ethical considerations are that, these kind of mechanisms and technology required programming. Here I'm going to talk about CAPL programming, can access programming language, Python programming language, in order to develop the programs, in order to take the decision not to commit with the accident scenarios. Human life is going to be a very important prioritized, right? So in order to make such a bug-free technologies or maybe a devices, programming decisions are much more plays important role. Clear? Yes, obviously, adoption challenges are requires a lot of technical knowledge. I think embedded developers are going to be develop such a challenges to be achieved. So autonomous vehicles infrastructure, you need to understand how the advanced mapping and algorithms and machine learning techniques, all these are going to be organized as part of the miscellaneous integration part and infrastructure to be developed. Clear? So the main public perception and trust is that, obviously, self-driving cars will be built a trust because they're better the reliable than the human being. Therefore these devices are highly recommended. The conclusion I'm going to give you is that, self-driving cars hold the immense potential to transform the transportation, and their successful integration requires technologically and obviously, scientifically, conceptually, programmatically, mathematically, we supposed to do that. See, I required, everyone, I request you to be, can you connect again? You can connect because I'm using the free version of the Zoom link because I need to record every section and I have sessions because I need to upload every session onto the public places. Therefore, I'm not going to use. If the connection is going to be disconnected, I request everyone to be rejoined for the class so that I can take some more some more discussions about it. You can interact with me if you have any questions.